So to introduce our panel is Thomas Whitmeyer, the Deputy Associate Administrator for NASA's Exploration System Development Team. Sir.
Okay, I'm going to say a few words and we're going to introduce the panel. So for the folks that heard Pam talk at lunch yesterday, she told you that we were going to put out an economic impact report. It did go out. I highly encourage you to go take a look at it. It's got some really cool stuff. We had at the dinner last night, we have Liz Barrios talk, and it was fantastic. So all the students here, if you haven't met Liz or didn't see a speech, I wish we could get it to you. It was super cool. And Jody, your presentation yesterday in the morning was a highlight for me. I called my wife up after it. Yeah, and the thing that Jody said is that you don't have to check all the boxes to be part of this team to do this type of stuff that we're doing. So I'm going to introduce some folks here in a second, and I want you to take the time, students. It's okay to come talk to us. Don't be afraid to talk to us. Don't be afraid to come ask us questions after the session. This is your opportunity to talk to people who do this for business. If you like the video that we just showed and you want to do that in your future, this is your chance to learn more about how to get involved in this stuff. So that's why we're here, and please come talk to us. We like talking to students. So I'm the Deputy Associate Administrator. If I had one more A in my name, I would be parking the cars outside. That's how they do in the agency of Administrator, Associate Administrators, and Center Directors. And by the time you get to the Deputy Associate Administrator, you get to park the cars. But the cars are in front of a really cool rocket. And so I'm happy to have that. I'm going to introduce some folks here. If you were down at the Kennedy Space Center, we have a big building called the VAB. If you go back and take a right, that's High Bay 3. That's where the rocket is right now. We had to put it in there to protect it from a hurricane that literally just passed right over. Janet knows this. It passed right over Florida. The eye actually went over our facilities. And so we were happy to get it back in the barn. And we're going to take it out. We're waiting for our window to open up June 14th. It's going to roll on June 4th. It's a super cool. I'm sorry, November. Somebody, I thought we were talking June early now. And November 4th, I'm sorry. And we're really looking forward to that. If you haven't seen it, you know, we're spoiled. We get to do this for a living, and it's there's no video, there's nothing that could possibly describe what an incredible rocket it is, and the capsule. And we have Europeans as part of our mission, and it's just a really great thing. So let me go ahead and introduce the team here today. But we are in great shape. We're getting ready to fly the rocket, and so we're going to go. It's alphabetical. First of all, Steve's going to come up here as soon as I get done. Steve, I want to tell you something. We're surrounded by space all the time. And so people talk about how NASA inspires people and stuff like that. Going into space is inspiring, but it's the people like you that talk to people and explain this and make it available to the public that makes space inspiring. So on behalf of the agency, thank you very much. You're a great person, and we really appreciate your reporting and taking our message and giving it to our people. So we really, really appreciate that. First up is Mr. Honeycutt, John Honeycutt. Jody and I love John Honeycutt. He is in charge of the SLS, the rocket part of the equation, and he's a wonderful guy. I've known John for a long time, and he's a great person, and he does the rocket. Howard Hugh, which is right next to John, he is the capsule guy. So that's it. At the very top of the rocket sits the capsule, and Howard's responsible for that. Doug is from Northrop Grumman, Doug Hurley, and some of you might recognize Doug. He actually flew this shuttle. I'm an old shuttle program guy, so. And he does the motor. So the things on the side of the rocket is what Doug produces in their facility in Utah. And it's a wonderful place to be. Tonya, next to Doug, is responsible for the capsule. She works with Howard. And the capsule is the first capsule that'll go to the moon and back. It's got about a month-long mission coming up uncrewed, and then we'll have a crewed flight. And it's just an incredible piece of hardware. Okay, next to Tonya is Randy Lycans, and Randy's with Jacobs. And Randy's sitting next to Jeremy Parsons, and basically Randy and Jeremy are responsible for processing the vehicle. We have entrusted it to them right now. They are taking care of our rocket, and they will get it out to the pad, and they will help us launch it here in November. John Shannon, I've known John a long time, a former shuttle program manager, and now is the manager for the core stage. It's an incredible job, and John, we're really happy to have you as part of our team. And Jeff Zotti, Jeff is Aerojet Rocketdyne, the engine sitting at the bottom of the rocket. Jeff's folks do that. It's the most complicated piece of machinery built by mankind. And it's the most capable engine that's ever been built. So we have a great panel of folks today. Steve's going to come on up and ask questions. Feel free to ask questions at the end of the session. That's why you're here today. And then please come talk to us at some point this afternoon and actually talk to people who do this for a living. If you want to be in the next video that comes up, you got to at least talk to folks like us, and we'll tell you how to get that opportunity. And with that, I'm going to give it to Steve.
I want to take care of one bit of business. Marcia Lindstrom, who's in the room, was named communicator with the Communicator of the Year, the Communicator Award for the National Space Club. Raise your hand. I would have done that better, but I can't read my handwriting. By the way, I have something with me that nobody in this room has. I have my wristband from the Von Braun Centennial WWVBD ? What would Von Braun do? So we can talk afterwards if you'd like to purchase this from me. All right, we have a lot of good questions and we really do want a little bit later you to ask questions. So be listening to what they say. And I'm sure that you're glad to be surprised. I have this is working. Y'all can hear me, right? I'm sure they want to hear questions that they've not thought of yet. So be thinking of good ones, but I think you heard one sentence and that's it. All right. First question, of course, for the former astronaut. Are you a former astronaut or are you always an astronaut?
I don't know.
I think you're always an astronaut. Anybody who's seen a shuttle launch, for instance, two things I thought, I can't believe somebody's on top of that. And I can't believe somebody would do it twice. And you, three, okay, so he's even better than I thought he was. All right, from the perspective of a former astronaut, why is this first mission so important to human spaceflight?
Well, I think you said it right there, human spaceflight. We've got to make sure the hardware is ready to go when we put crew on it for Artemis 2. So for me, that's extremely important. We did a very similar, we weren't able to do that with shuttle, if you remember. So when John and Crip got on that vehicle, that was the first time it actually flew. And there were reasons we had to do it that way. But for this vehicle, we were able to do an uncrewed end-to-end test flight. And I think it's hugely important to work the system completely through the entire profile so that when we put our astronauts on board on Artemis 2, we have the ultimate confidence that we're going to be successful. And then to add to that, and it's something that we at Northrop Grumman and Aerojet build the launch and board system. It's not going to be on Artemis 1 for obvious reasons. We don't have crew, but that has been heavily tested and will be on Artemis 2 as another way to ensure that our crew will be safe throughout the mission. And so it's just this is just a great way to do testing. Build up approach, test the vehicle, test the hardware, then put the crew on for the next flight.
Okay, so you're the only one who gets a two-parter. By the way, the camera's over there. As much as I like you guys to look at me, you probably ought to look over that way.
Look at the camera.
Besides that way, I can drink water and stuff and nobody will pay attention to me. All right. Compared to the shuttle, we've added a segment to each booster. How do the boosters play a role in your mind in the success of Artemis 1?
Yeah, the boosters give the vehicle for the first 2 minutes the majority of thrust to get it into orbit. So it's about 3.6 million pounds of thrust per booster. So 7.2 of the 8.8 million pounds of thrust at liftoff of SLS is going to be those solid rocket boosters. So we're obviously very proud of those pieces of equipment. They're amazing, 177 feet tall. Having ridden on 4-segment boosters with the shuttle twice, these have 5-segment boosters, so about 25% more thrust. It's going to be a very exciting ride for that Artemis 2 crew and beyond for those first 2 minutes and about 8 seconds. I equate it to riding in a 1950s Jeep over a gravel road as fast as you can drive it. And that's what it's going to feel like. And Honey was talking about it earlier. You're going someplace and you're going someplace in a hurry as soon as those things light. So, we're confident that those boosters are going to be do exactly what they were designed to do. And for those first 2 minutes, hopefully on the very early evening of the 14th, they're going to light up the Florida sky pretty well when we launch Artemis 1.
Okay. This is one of those, it's a what question, but I feel like it needs to be a what and things you learn. Can you tell us what happened on the first 2 launch attempts, Jeremy, and what did you learn during those attempts?
Yeah, so good question. I appreciate it. let's see, for those of you that were at the dinner last night, the teacher of the year used a quote that it kind of resonated with me on this topic. And I'm going to absolutely butcher it, but this is the gist. He said something like genius is a series of small efforts and, overcoming failures. And so when I think about our first 2 launch attempts, in my mind, I probably changed that to something like making history is a series of huge efforts and overcoming challenges. And so when I think about the first 2 launch attempts, that's exactly what our team did and did extremely well. During the first attempt, we battled through just a numerous series of things, right? We had lightning, which delayed us for about an hour. We had a small leak, which we overcame. And eventually we got the entire vehicle fueled. But then we did have a violation on chill down of the RS-25 engines. What I was so impressed with is the team came out of that, immediately came up with troubleshooting data and analysis, and we got into another attempt just a little bit later. That second attempt, I was sitting there through the night, and it was quiet and smooth, and I was holding my breath because this was not how anything had gone to date. And we were ahead of schedule. And then as we got into hydrogen loading, we did end up with a leak there. And so we tried a series of troubleshooting steps. Ultimately, we weren't able to get past the leak. Again, the team stepped back and said, how could we do this differently? We changed that as seal. They changed procedures, and we're able to recover incredibly quickly. And we were able to get into a tanking test, and we validated some of those new ideas, and we were successful in loading the tank. So where are we at now, right? I think we have good procedures to go load the tank. I think we got the hardware in excellent shape. And I think we have a team that's been put through the paces a number of times, and every single time gets better, more knowledgeable, and works together as a more cohesive unit. Hurricane Ian chased us off the pad, as Tom mentioned. Otherwise, I think we could have gotten another launch attempt off. But that's okay, because we got 3 bites at the apple here in early November, and I'm pretty excited. We're on track to roll for November 4th.
All right, this question for John Honeycutt. All right. We know you have faced challenges with the umbilical seals, and a lot of hard work has gone in by a lot of people to fix the issue. Can you describe the process and how your team performed, especially during the last tanking demonstration?
Yep, sure can. Thanks, Steve. Yeah, so I want to emphasize something when I start describing this first, that it's not my team. It's our team. It's the enterprise team. And so everybody that's part of this enterprise plays a part for getting the hydrogen leaks repaired and getting the rocket ready to go do the tanking test. It was an effort primarily led by EGS and SLS, and we all had our roles and we worked extremely well together throughout the process. SLS being the design center for that part of the rocket, that interface where you load the hydrogen. We did quite a few tests at Jeremy's test facility down at KSC with that umbilical configuration leading up to stacking the rocket. And so we learned a lot during those tests. But what I will tell you is, that hydrogen molecule is very small, and however, it is extremely energetic. And so it's worth us being able to give the astronauts the kick in the pants that they need to get them where they're going and get us support performance that we have to have. So, old folks like me can look back and remember where we experienced similar challenges in the space shuttle program when we used liquid hydrogen as a fuel for the RS-25s. So just a little bit about kind of the thought process and where we went to. And so I got to kind of lay a little bit of groundwork there too. I tell folks that for the SLS rocket, we had to build the system along with building the first rocket. And so I think we did a good job at that, and we got the system in place now. And, that's kind of evidenced by we've got four additional core stages and other hardware for the next 5 flights in flow today. But I say that in that, when the rocket showed up at Kennedy to start the assembly process, it was a learning experience for Jeremy's team and our team too, because we hadn't put the rocket together yet, right? And so you get the right, we did, I think we did a great job putting the rocket together. We did have those couple of launch attempts that Jeremy described, and ended up on that attempt where we had to leak and had to scrub. So again, it was a total team effort. And so just kind of the gist of what we did decide, make a collective decision by the leadership team to stay at the launch pad and build an enclosure at the launch pad to protect that area where we needed to do the work on the umbilicals from the external environments. Got that done and got in and did a series of operations basically that demated the umbilicals at the pad, inspected the seals, did see some little bit of indication on the 8-inch seal. The 8-inch seal is the one where we do fill and drain the liquid hydrogen tank, and then the 4-inch is in that same umbilical, and it's the vent system. Replaced those, got them put back together. And so that was kind of the summary of what we did on the hardware. But at the same time, we were scratching our head on, what can we do different to put ourselves in a better position so we don't encounter these leaks again. And one of the things that the combined team did was looked at how we are moving the liquid hydrogen from the storage sphere on the ground side and to the vehicle, and made a conscious decision to do what the team called a kinder, gentler approach to loading the hydrogen. And the way I like to look at it is you kind of make sure you got a good cold interface there, because when you want to have it evenly distributed across the interface, not have any warm spots in one area. And so we were able to do that. And then we changed the way we moved the hydrogen from the storage sphere and through the lines on the mobile launcher up to the vehicle. And in doing that, it showed us that we were able to get through that transition period in that thermal environment, and then slowly increase the pressure to load the vehicle. So ultimately, we had a great test. We ended up loading the vehicle with hydrogen, and we were able to do what we called our engine bleed kickstart test. And so I was extremely pleased with the results. We did have a little bit of a leak occur during the new procedures that we were running, but we worked real time through a process to get comfortable with that. And so, and we're able to complete the test. So overall, really outstanding combined effort by the team.
All right, Jeff, next question for you. And you're allotted 60 seconds. Just kidding. Can you summarize the RS-25 engine chill down process that we'll be doing on November 14th to get them ready for the launch?
Yeah, absolutely. So obviously, thermal conditioning of the engines is critically important to engine operation. The RS-25 engines see extreme temperatures from minus 423 degrees Fahrenheit in the liquid hydrogen, all the way up to 6,000 degrees in the combustion chamber. And so what we want to achieve is a homogenized, fully saturated, chilled state before we start the engines. And that could be a gradual process. And so what we've done to accelerate that process is we use a kickstart procedure at the beginning of LH2 fast fill. And what that means is it's a combination of vented bleed flow and an increase in tank pressure, and that pushes more of this chilled liquid through the engines to get them to the thermal conditioning requirements that we need. And that technique was successfully demonstrated a month ago at the tanking test.
Okay. All right, John Shannon, as we, in the TV biz, you always want to advance the story, so you get to do that. As we're waiting on Artemis 1 to launch, what else is Boeing working on to prep for Artemis 2 and beyond?
Yeah, thanks, Steve. So our main focus really is, right now is Artemis 1 to make sure that we support Jeremy and Randy's teams, to get the vehicle in a good config. It shouldn't be lost on the team that, as John said, we had the vehicle fully fueled, ready to go during our last tanking test. So we feel very good about this, this upcoming activity. We build, the core stages, that's the big middle orange part that carries Jeff's engines, at the Michoud assembly facility in New Orleans. That facility has increased capacity and hardware over the last year and a half in an amazing way. So right now we have core stage 2 is going through its final integration and testing, and it will be rolled out of Michoud and sent to Kennedy Space Center late next March. So it's coming right up on the heels of Artemis 1. We have the Artemis 3, 4, and 5 core stage vehicles also in flow, as John said, and they'll follow at about 1 year centers after the core stage 2 comes out. So if you went down to the Michoud facility, you would see a lot of hardware in flow. And there's one special area, it's affectionately known as the gray box. That may be the color of the walls around it, but that's where we're setting up all the tooling to build the exploration upper stage, which will start on Artemis 4. And it provides a capability not just to take Orion and the service module to the moon, but also to take up to 12 metric tons of other hardware, things like the gateway facility. And that's going to add just another dimension to this entire program, starting with Artemis 4.
Howard, Artemis 1 will soon be on the pad and ready to go. How far along are you on the vehicles for 2, 3, and 4?
Yeah, Steve. Let's see. So, John mentioned where obviously the core stage is at for Orion. We're also obviously very focused on Artemis 1. It is our stepping stone to our ability to go to the moon with the Artemis program. So we're building not only supporting Artemis 1, but we're building the Artemis 2, 3, and 4 spacecraft, all in what we call concurrent development efforts. And I'll just give you some highlights. Artemis 2 is at KSC, ONC, both the crew module and the service module. They haven't been mated together, but we're working through all the final testing. So all the functional testing that happens in the crew module and the service module across all the major subsystems like avionics, propulsion, and ECLIS. So very important. And of course, one of the really important things Doug talked about, getting ready to support the crew. One of the things is the displays. We've got the displays in the crew cabin for the crew module right now in Artemis 2 spacecraft. So that's really great news, really great progress there. We're going to finish up additional testing the rest of the next few months. Then we'll wait for some return hardware for Artemis 1 for avionics that we're going to reuse on Artemis 2. And we'll put that in, we'll do the final testing, and then we'll stack the vehicle together and roll out the door and let Jeremy and the EGS team get that stacked with the rest of the space launch vehicle. For Artemis 3, we're also working that. The crew module actually for Artemis 3 primary structure arrived from the Michoud assembly building or facility back in October. And we've been putting secondary structure components in there and getting that ready as well and bring forward hardware for Artemis 3 crew module. We've also got the crew module adapter that's in the clean room, and we're doing all the welding of the plumbing that's needed in that as well. And of course, the Europeans are working on their side of the service module, which we call the European service module. And they have the primary propulsion and solar arrays and power generation capability. And so they've been working very hard to get their equipment done and deliver next year as well. So we'll have the Artemis 3 crew module and service module next year. And finally, on Artemis 4, we've already got almost all the major welding done on the crew module on the primary structure at MAF. Really great progress there. We've got one more weld to do coming up. And then that crew module is also going to KSC in next February. So we've got all these vehicles that we're working through across various stages and maturity of production and installation and testing, and really excited about the progress we've made. And of course, demonstrating all the capabilities that we have on Artemis 1 is going to be awesome. So thank you.
Thank you. Tonya, how's Artemis 1 demonstrating Orion's reuse features, and how will that impact future flights?
Sure, and Howard already alluded to this, that we're going to be reusing some of the electronics and avionics from Artemis 1 to Artemis 2. But Lockheed's always had that plan to do that reuse. We've committed to reduce our production costs by 50% in the out missions, and a key enabler for that really is the hardware reuse. So we eventually are planning on actually reusing the entire crew module on future missions. Artemis 1 is actually already demonstrating that reuse. We're reusing a couple of components from our EFT flight test mission. We have a battery from that mission and two flight harnesses from that mission that we're using on Artemis 1. And as we look to the future, we'll be looking Artemis missions 2 through 5, reusing some components that are, some of them are refurbished to the order of like 600. And by the Artemis 6 mission, about 5,000 components will be reused between our vehicles and the missions.
All right, Randy, you get the longest question. Everything comes together at Kennedy Space Center where flight hardware is prepared for launch. Can you talk about what it takes to integrate all the components? And no, we don't have another hour, but could you do that? And while you're doing that, can you talk about the Jacobs and EGS team at KSC prepping for launch and the challenges they have faced?
Sure. Thanks, Steve. Can you all hear me? So what I would use to describe this, what we've had to do to make this happen is really about teamwork. Okay, you've got the internal teamwork within the EGS and TOSC contract team, but what we saw through the flow of this new vehicle, we've got a lot of new processes, new hardware that nobody's put hands on before. So there's a lot of teamwork that happened between the various element primes, the hardware providers, Boeing and Northrop and so on, that collaboration really contributed tremendously to the success of getting the vehicle stacked and integrated and tested out and ready to fly. What we've seen, Jeremy and I were talking about this before the panel, each time we've gone through a flow where we've had to work through the wet dress rehearsal, for example, figuring out the loading procedures. We've come up that learning curve significantly each time. And each time we've made a step up that learning curve, it's been contributions across the entire team that have really made that possible. So that's a key aspect, I think, of our success so far. The challenges, I think, are twofold primarily. Obviously, trying to get large teams working together hands-on on this hardware through the COVID pandemic has been a significant challenge, and it's impacted the entire workforce. Okay, all of us down there working together at the Cape. The other thing is it's a new environment. If you were down there at KSC after shuttle, it was a ghost town. It's not like that anymore. There are opportunities all over the place, and there's a lot of competition for workforce. So our workforce development, our workforce retention activities are critical to facing the challenges as we go forward.
Okay, Howard, another question for you. The November 14th launch means a shorter mission than the very first mission would have meant. Are we missing out on any opportunities that we would have had on a longer mission?
Yeah, well, I would say the short answer is no. For Artemis and for Artemis 1 specifically, Doug alluded to, we're checking out really 4 major objectives. First of all, we're really trying to get lunar return entry speeds for a heat shield. I mean, that's really important to protect, obviously, the crew and the capsule and be able to reuse, like Tonya's talking about. We're checking out all the other major subsystems as well as part of Artemis 1. And of course, one of the demonstrations that we want to make sure we successfully do as well is also the parachutes. So having that opportunity, we're going to fly 25 days, almost a month. So when you think about short class duration, it's not that short. And so from our perspective, we're able to demonstrate and be able to successfully achieve all those objectives and more, I would say, and then really check out those subsystems that are needed for future flights. And so we feel real good about whether it's 25 days or 40 days, I think we'll get everything we need.
Tonya, we've heard about the Callisto payload that Lockheed Martin, Amazon, and Cisco are flying on Artemis 1. What is that? Apparently, I'm the only person who hasn't heard about it. And how can the public participate in this during the mission?
Sure, thank you for asking that question. It's actually really exciting. It's a we partnered with Cisco and Amazon to develop Callisto. And it's really a technology demonstration payload, and that interfaces with the Orion crew module. It's actually inside the crew module. And so we'll have virtual crew members that are be hosted out of NASA Johnson Space Center that'll be actually interacting with the Callisto payload while it's on the flight. There'll be some great, there's a 360-degree camera to be able to look around the crew module. We'll be able to host and see and interface with the Orion vehicle. And it's really a great way to demonstrate what it might look like in the future for that human-machine interface for the astronauts. We're demonstrating this technology, so it'll give us an opportunity to look at ways that technology will help make their jobs safer, more effective, more efficient in the future. And if, as far as how you're going to stay in touch with it, you'll be able to, go to Alexa and say, Alexa, take me to the moon. It'll tell you now what our plans are to go back to launch on the 14th, but then you'll be able to follow it along. And actually at lockheedmartin.com/Callisto, you'll be able to see the control center testing and that unique mission imaging that I talked about with that 360-degree view. So it'll be a great way for all of us and the public to interface with the Orion mission and also look at what that technology could be for the astronauts in the future.
I cannot wait to say, Alexa, take me to the moon. Gonna do that. All right. Jeremy, exploration ground, you have a two-parter, but I'm not going to ask you the second part till you finish the first part. Exploration Ground Systems in Jacobs currently working in the vehicle assembly building, preparing SLS and Orion for the next launch attempt. What can you tell us about the work that's being done right now?
So right now, it's a pretty darn exciting time. Just take a look at the picture behind you, right? So the SLS stands over 320 feet tall, and it is one heck of a photogenic rocket. So all of that entire stack on top of that mobile launcher is in the vehicle assembly building right now. We're in some of the final phases of closeouts, and then actually going into next week, we start testing what's called the flight termination system, which is begins a clock with the range essentially in terms of final testing for the batteries and things along those lines. The team, since we rolled back into the VAB, has been going essentially around the clock, and we've been pushing them really hard. But I will tell you, they stepped up. Right after that, we had to roll back for Hurricane Ian, right? I think for all of us, it was a little bit of a collective gut punch. And you know what? That team got up the next day after that and just got after it. And so they have hit every scheduled milestone since we got back into the VAB and really overcome a number of technical issues. Right now, we're on track for a November 4th rollout and then a 12:07 a.m. launch on November 14th. We're not tracking any real significant technical issues. We're working through some things still, as you would expect, but it's going really well.
The second part, now, it says one word, but I'm going to give you one word plus an explanatory sentence. If you had to describe your team with one word, what would that word be?
Resilience. Starting a couple years ago, we were in a pandemic. It hit Florida really hard. It hit our teams really hard. We lost a number of team members. We had to learn how to work in a different environment. We had to learn how to integrate a vehicle across, a number of different programs altogether. And the team has really fought through with resilience, technical acumen, kept pressing through hurricanes, wet dress rehearsals. And so I can't really be more proud of the team that has come together, their perseverance, and it's been a real blessing to work with them.
Which one are you going to go with? Perseverance?
Resilience. Sorry, I apologize.
Okay, John, in the past, you've compared the experience building your own house with leading the SLS team. Anybody who's watched HDTV knows that stuff crops up all the time, and I think the comparison gets even better. How has this philosophy affected your leadership style as you weather all the challenges and delays inherent in building a new rocket?
Okay, thanks, Steve. Yeah, I think one of the things that I was fortunate to learn early in my career was the value of building relationships. And so, yeah, I did build my house several years ago. I subcontracted some of the work, but when you got to do that, you got to develop relationships with folks, and it's got to be an integrated activity, right? And it's you got a lot of important details in a house that you don't ever see, but they're important to you. And we've all been through those experiences. somewhat similarly, the rocket, much more complicated integrated systems. And the thing you got to do is you got to build those relationships, right? So I've got a great relationship across everybody that's on this panel, and Tom and everyone else. And that's a key component in us being able to get the rocket built and ready to go fly. I think it's my job as a leader is to trust the team to do what I've asked them to go do. And then also challenge the team when I think they need to be challenged, and then help the team when they need to be helped.
All right, Tonya, a couple of y'all have already alluded to working through COVID. The pandemic obviously had a significant effect on everything, and especially on NASA and building a new space vehicle. Workforce and supply chains around the world were certainly impacted. How did Lockheed Martin fare from an Orion standpoint? And what techniques did you use during the workout?
You know, we also suffered from many of the same things, right? We had to be resilient. We had to work in different ways. We had raw material delays. We had material pricing increases. Our lead times had growth. We worked with our suppliers and our sub-tier suppliers to try and mitigate that. And the good news is for the most part, we had some cost growth, but it wasn't untenable. And folks really rose to the occasion, being committed to the mission. I think that's a big, you asked what's an enabler for that too. I think when we're all focused on a mission like this mission, and we want to see Artemis 1 get launched, people but double down, right? Even in the face of adversity. And we saw that with all of our team, whether it was our suppliers and their sub-tiers, working with our customers. It was a true team commitment. It's not different than what you expressed earlier.
Okay, these are great answers, but I want to make sure we have some time for Q&A. So I'm going to ask a question, and basically raise your hand if you would like to ask it, answer it rather. As we learn from the development and conduct of the Artemis 1 test flight, what technical or operational enhancements are your teams considering as we move forward? Anybody want to jump in there?
So we have taken, so for the Orion offline flow alone, we've taken over 400 lessons learned. We already have teams starting to work on how we can improve each one of those things, right? So while we've been improving drastically throughout the entire flow in terms of technical coordination, risk acceptance, things like that, throughout the entire flow, we've been taking actions, right? And I already have a series of procurements in place for new access stands, for new suits for hazardous operations, communications updates, things like that. And so we've already named kind of a lead from each one of the major programs for those lessons learned, and are in the process of burning those down because, again, we know we are going to get continuously better as we kind of go through it. So that would probably be my quick response.
Anybody else want to tackle that one?
Yeah, I'll take a shot at it. We're always looking to the future, right? And where can we get better? And I know one of the things that we always have continued to look at is what we call mass optimization, right? Where can we take weight out of the vehicle at some point along the way? Now we can't do that today. We've still got to fly this first test flight, but I believe we'll get data from the first test flight that helps us put ourselves in a position where we are able to increase our payload capacity in the future.
Anybody else?
Yeah, I'll just add on to Jeremy's, I think one of the things I saw today was about collaboration, right? And we talked a lot about it. I think it's been great. Tonya and I and Jeremy just decided on something. We're going to be able to save some significant days on our critical path for Artemis 2 and beyond by changing up how we actually put the LAS on, and the work that would need to be done on the Lockheed side versus being done on the EGS side. And I think this is a very good demonstration of how we work well together and looking at across from the enterprise and breaking down those barriers in terms of not just, hey, it saves me time, but it impacts you. But we look at it together and go, what's the best benefit for the enterprise across the board? And I think that theme and that kind of work that we're going to have to do going forward with these lessons learned or with what we find from the flight is going to be really important as a partnership that we have across all these programs.
Anybody else have anything they want to add?
I'd say one thing,
we've learned a lot in how to build, how to integrate the entire vehicle, but our biggest learning point is going to come hopefully on November 14th, right? This vehicle has a suite of over 1,000 sensors that will give us all the information that we need to know to understand how the vehicle performed. We've got the teams and analysts all ready to go dissect all that data and feed that back into it. So before we put a crew on it on Artemis 2, we have the safest vehicle we can possibly fly. And I think that's the most important thing, is that the team is ready to make changes to vehicles as required based on what we learned on the first flight. Yeah, and I just want to add, for the RS-25 engines, we're not significantly changing the design because we want to preserve the safety and reliability of our heritage configuration. But what we are doing, starting with Artemis 5 and beyond, is modernizing the way we make the components, using a lot of things like 3D printing, and that's helping us to drive a 30% reduction in cost going forward.
All right, we have 2 microphones, and we are proud to bring them to you if you have a question. And raise your hand. I hope you do. Somebody up the top so as to run up there. I guess they're down here. Anybody with a question? Okay, right over there.
We'll go with this gentleman first. Jeff Faust, Space News. Question about the launch period. I know you've got the 14th, 16th, and 19th reserved. The launch period runs through the 27th. I'm curious how usable the rest of that launch period is if you're not able to get off the pad by the 19th because of cutouts and potential airspace issues over the Thanksgiving holidays.
So I guess I'll take the first crack at it. So there is an opportunity to get a 4th attempt within that launch period. What we have to work through is a series of kind of like what you said, right? Over the Thanksgiving week, there is a kind of essentially clear of the airspace over there. I can't remember the exact term for it. I think it's HARP. But essentially, we'll have to work through that. And I do think we would be able to get a 4th attempt on 11/25, but that would be a series of discussions that need to occur with the FAA. But we've already put all the plans in place to allow for additional commodity to be brought in, contracted, things like that, if we think we need that.
Hi, my name is Jacob Goldenberg. I'm a NASA Marshal engineer. I actually work directly with Mr. Zotti's team. So just a question about the core stage flight termination system. We saw that the range extended it to, I think it was like 45 something days. What lessons learned are we going to have going forward? Are we going to be able to service this on the pad? That seems kind of tricky. Or are we going to get longer extensions from the range? Just curious about, if we ever run into these issues in the future. Thanks.
See, John, am I answering that one as well?
Yes, I think we own this one together, really, right? So I'll answer. I'll kind of give you a little bit of it. So we did work with the range during the last launch period to negotiate an extension on battery charging at the launch pad. I think as many people know, we don't have access at the pad. We do have data available to us to show us how the batteries perform. The launch director, the SLS chief engineer, and the SLS SCNI manager all work closely with the range at Kennedy to get to a place where we satisfied them that they were able to clear us for a launch attempt up to that 50 some odd days, right? That was conditional though. It was a one-time deal, and we have not entertained going back to them just yet. So we kind of had that discussion in one of our meetings over the last couple of days, and that's kind of where we are.
So Mr. David Beeman and Dr. John Blevins, working for John, really led the technical aspect of it. We led a number of the scheduling aspects. Your broader question, right, about access. What I would say is I don't think any decisions have been made, but we recognize some of the challenges that we ran into, both with time durations, processing, and then the sort of position that we put the range in, needing to sign a waiver. it is absolutely something that I've actually kicked off a study to go look at. What it would take, what is the cost, what is the timeline for implementation? And we are brainstorming different options, but it's for that and other things, right? So it's kind of a all encompassing. So I don't think we have an answer yet, but we recognize we want to look at and make some intensive and intentional decisions.
Hi, my name is Irian Waldron. I'm an undergraduate here at UAH. And so I've noticed that some of the focal points of this symposium as a whole and this panel specifically has been communication. And from a communication standpoint, it's very clear that things have gotten a lot better, especially since like the Challenger and the Columbia disaster. So what specifically has changed about the culture and communication in your teams and organizations over the last 20 years?
I'll take a shot at this one. I'll give everybody else a little bit of time to think. So I was fortunate enough to be the external tank manager at the end of the shuttle program. I was also unfortunate that we lost the Columbia crew, and I got the opportunity to participate in the investigation team. And the key thing for me and what I learned relative to that particular accident and the communication, right? It's our job as leaders to challenge folks and make sure that they're getting the questions asked that we may have missed or just forgotten about, right? Or point out something that we've overlooked. So, long and short of it is, anytime I have an important review, even leading up to the end of shuttle and now NSLS, it's my job to look around the room and read faces and ask questions. It's not enough just to assume that everybody in the room understands going to ask questions. And so, everybody's got different personalities. And so as leaders, you got to draw that out.
Yes, it is. Hey, so the baseline plan has been that the second Artemis launch, assuming a fully successful mission, will be in about 24 months. Some of that's driven, I know it's an Orion issue with the avionics that needs to get reused. Just wondering, knowing what we know now, how confident are we with a 2-year going forward, assuming everything goes well after November 14th and everything, we have a really nominal launch and a good mission?
I'm highly confident from an SLS perspective. I'm in a position right now where we're going to deliver hardware probably a little earlier than Jeremy needs it to EGS for the mission.
You're not going to hear any complaints from us. We want to be hardware rich. Now, so one of the, Orion, obviously we got to get the avionics back to Orion. One of the big things that we're doing from a ground system standpoint is we're adding crew emergency egress for the mobile launcher. And so we're doing that. We're also upgrading our hydrogen sphere. So we built a new hydrogen sphere that's got over 1.4 million gallons. It'll allow us to get more back-to-back launch attempts, which is a huge capability, as you kind of see where you got smaller windows, things like that. So in terms of where we're at, we do have margin in that schedule. We're very confident in where we at. We already have all the major items fabricated and waiting for the mobile launcher to show up to begin work. So feel pretty good there. I think, from a processing standpoint, I think our procedures are in good shape. We've nailed down a lot of the learning curve. And in that 2-year time frame, that learning curve is built in there. So, we did do the analysis and modeling to kind of say, this isn't completely blue sky or anything like that. It's a very reasonable schedule.
Yeah, I'll say from a Orion perspective, I would say that we certainly are waiting for the avionics. It's a handful of avionics. I don't, that's not the only principal driver for our Artemis 2 schedule. We've got a lot of testing, we've got new hardware that we're putting in ECLS and all the crew systems. So certainly a challenge, but we're doing a lot of things, not only very well because we've done it 3 times now with the crew module, but we've learned a lot in terms of what kind of things we can be more efficient in. with technology, and Tanya's team has done a great job of looking across the board and implementing those things as we go forward. So our schedules, and we look at those schedules very closely every day, and we're managing those schedules at a looking at from a risk perspective, but also from, hey, what have we done before? And can we be more efficient with what we've done before, because we've learned those lessons already through multiple builds. And I think that's helping us a lot in maintaining that pace of schedule. So from our perspective, we're managing the schedule tightly, and we're looking for opportunities to go as fast as we can. And of course, we want to build a very safe vehicle for the crew, and demonstrating these capabilities for Artemis 1, and of course, implementing new systems will be very important.
And if I could just address even the reuse part of it too, one of the benefits we get with having the OPOC contract and the multiple vehicles that the government's purchased, right? We have those vehicles in flow. So even though we're using 16 avionics from 1 to 2, we're now pulling 8 of those forward from 3 and from Gateway to mitigate the launch slip impacts, right? So it gives us a lot more flexibility too when we have future production orders, and we're looking at ways we can get more sparing on the Orion vehicle too to help enable that.
Hi, I've got a two-parter from an online attendee, Irene Klotz from Aviation Week. And it's related to the flight termination system. So I'm not sure if these are answered before, but when does the new certification period for the SLS flight termination system end? And related, what is the status of development of the SLS automated flight termination system?
So I think you got the part on when you start the clock and when it ends.
So for the first one, we're essentially able to get through those first 3 launch attempts, and we're in good shape for that. So.
And what was the second question?
What's the status of development of the SLS automated flight termination system?
Yeah, so we're not due to have that and fly that until Artemis 4. We are planning to do some test flights on a NASA airplane here in the near future. I do think that we are in a position to be able to implement the autonomous flight safety system on Artemis 4 based on the schedule that we've got laid out today.
Very good. You got some up here?
Hello, Rodrigo Romero, undergraduate student from Iowa State University. The main purpose of Artemis is to send humans to the moon again. What are the main aspects in terms of human health and well-being that Artemis mission is taking care of?
Yeah, I'm not sure I can answer exactly what you're saying. I think from a human health perspective, we're obviously certainly wanting to have the crew be safe, number one, and operating the vehicle and be healthy when they return. And so radiation protection is a big aspect of it. And so we've got a lot of radiation sensors for Artemis 1. So we could see and ensure what kind of environment that the crew would get involved with. Of course, crew exercise to ensure their health as they're operating the spacecraft and living in space is also a big part of it. And of course, we obviously have a lot of experience living in space. And so we're learning from that from our human health perspective. And we'll be applying those going forward, not only nutrition and exercise, but all aspects of what we've learned on International Space Station are going to be important for us to be sustainable long-term in the lunar environment.
We have another question over. You got one gentleman over there?
Yeah. Okay. Does it work? Okay. Hi, my name is Max Haler. I'm an undergraduate student at UAH, and I just want to reiterate on the topic of ground systems and scheduling. And I was wondering, what is the process for the mobile launcher once Artemis 1 launches off of it, getting it back into the VAB, maybe cleaning it, and then getting it prepared for a second SLS?
Want to say thank you for actually being interested in the ground systems. Clearly the most awesome part. So it's a good question. So right now, I mean, it is a big risk as far as the post-flight damage. We got about 30 days that with which to clean it, do some nominal repairs and then get it back into the VAB. From there, we'll repair any damage. But really what we want to do is we want to get it out to that mobile launcher park site as quickly as possible. And so that's something that we've done an assessment of, what parts do we think we're going to need? Let's kind of order them ahead of time. We set aside budget links because, while we can model all we want, we're not going to know exactly the sorts of damage that's going to occur during that first flight. So luckily we have good folks that are looking at all that and preparing ahead. So then at the park site, what we're going to do is we're adding a series of a platform for emergency egress. We're updating a number of kind of systems and things like that. And again, kind of that LH2 sphere is kind of the big piece of it. We're then going to do a series, because now we've changed some of the configurations, a series of what we call verification and validation. And so some of that will be done in the vehicle assembly building, and then some of that will be done out at the pad. With the pad, we want to, again, run that LH2 sphere up to your ML base, make sure we're getting the right pressures, flow rates, no issues, manifolding, things along those lines. And then really a big piece of it will be testing our emergency egress system, making sure we're, hitting all of the expected loads onto that system, and then really kind of figuring out also how long that takes to set up so we can plan our pad flows appropriately. The only other mod that's really kind of a big one is ignition overpressure sound suppression. So we are changing some of those nozzles, and we're going to be running about 3 tests or so on that as well, just to make sure we got good water flow in the right areas. So
over here. I'm Zachary Taylor. I'm from the University of Missouri, Kansas City, master's student. Zotti's team mentioned that they were working with additive manufacturing and 3D printing. I was curious how that acquisition process has been going, and if that's done in-house or not.
Yeah, we've got 7 additive manufacturing machines that we currently utilize, and it's going pretty well. We've added about 39 components right now that we're using, and the advantage of additives is, it's reduced part count, it's reduced lead times of our hardware, and it's reduced touch time. And so I have an example, our POGO accumulator. It's like a shock suppressor on the engines. We've eliminated 20 different parts in that, and we've been able to reduce the cycle time by 50%. In early on, there was some learning curve, a learning experience, and how to adapt this new technology. But now we're beyond that, and we're just looking for more and more applications to continue to reduce costs. So thanks for the question, though.
Hello, I'm Peter Summers from the University of Alabama in Huntsville. I'm an undergraduate. I have another question for ground systems. There's going to be a second mobile launcher built for SLS-1B once that comes around for Artemis 5. What's the timeline looking at for the development and completion of that second mobile launcher?
So right now, ML2 is contracted with Bechtel. We are in the process of completing the design, and most all of those designs, again, will be kind of done within the next several months. And then really kind of what they're hot and heavy on right now is completing their fabrication, essentially design. So the drawings that we hand over to our steel fabricators. And so while we started some steel fabrication, the vast majority of those drawings will be done and over to the fabricators in the first part of 2023. In terms of when we deliver, we're post 2025 right now, and then we'll go into a series of MEV&V events. And right now, the Mobile Launcher 2 is the critical path to Artemis 4. So it's something that we're working the schedule very intensively on, adding shifts, looking at what we can compress, and things along those lines. But we just got a really updated, more detailed delivery from Bechtel within the last couple of weeks. So the team's assessing that and the exact schedule that kind of flows out from there, but it is reflected in the current manifest.
There's a question over here. From me. You've been stacked a long time. What's are there any concerns about propellant flow, propellant movement, aft skirt stresses, fatigue? How are those analyses going?
So good. I think we've got several more launch windows before we need to take another look at it. I mean, certainly it's something that we have at the top of our list to keep track of, and we'll just continue to analyze. And with any luck, we'll have the thing flying in a couple weeks.
Okay, we just have a few minutes left. I got to sneak a media question in here. As a media person, it would have been a lot better had you launched in the day. just because more people will see it. But did that even come up? And I totally understand things are driven by launch dynamics and all the equations that go into putting a rocket into space and going around the moon. But did it come up that, darn it, we wish we could launch during the day? When people will see it on television.
I think if you go to Florida, in a couple weeks,
Yeah,
it'll be a pretty bright light going uphill.
yeah. And you do have a point there.
Yeah. I mean, I think from a testing standpoint, and certainly I'll let some of the other folks jump in, but, we certainly looked at that when we flew DM2. You know, we wanted it to be a daylight mission for obvious reasons. Just so we could get the best imagery of the separation events and any of the other things going uphill that we could. And certainly it's a preference from the team, but as John said, we've got it highly instrumented and then just, yeah, a little plug for Northrop Grumman. The boosters will light it up pretty good for those first 2 minutes at 8 seconds.
No, for sure. Okay, last couple of questions. Howard, what are you most excited to see during Artemis One, during this upcoming mission?
Yeah, I think there's a lot of things I'm excited about. I would say, I mean, this is a historic mission. As we talked about, Artemis is our first step towards long-term lunar exploration. And, for me personally, I came to NASA to work on something like this. And I think the first picture of the moon as we see it from the Orion cameras that we have on our solar arrays will be very exciting. Of course, liftoff will be exciting, but I think seeing the moon and seeing that destination that we're going to be working together on for, I would say, this generation, all of us, and the next generation out there is going to be just an awesome moment.
Anybody else want to say something about that?
So I have two young daughters. I got an 8-year-old and a 10-year-old daughter, and so they're going to be in the area with me. And I'll tell you, they've grown up with their parents working on this program. And for me, looking at them like that's the part that excites me, right? Because, my youngest would build rockets out of a cardboard box and stuff like that, but they've never seen something like this. This is big.
Well, I know I'm excited. Okay, John, this is our last question. What do you think will be the legacy of the SLS rocket in terms of the future and the missions it can support? And also I think something about the people. That seems like a big legacy to me, the people who made it happen. How do you put this into perspective?
Yeah, so I got a lot of thoughts about what the legacy of the rocket is going to be and, what the future missions are going to look like, but I tell you that, kind of looking backwards, we always like to talk about we built, our success has been built on the shoulders of giants, from the Space Shuttle program, the Saturn program, Apollo and Gemini. But I really think SLS will earn her own place in history. And that's probably not for me to decide, but it's for the American public and the taxpayers and the people that support us to decide once they see and realize the capability of the rocket. This rocket was built really to get us back into the business of flying into deep space and carrying humans into deep space, back to the moon, onto Mars, and be a rocket that's got a capability to carry large payloads into space. We're focused on human launches now, but this rocket's going to be a game changer for our country. I think far as its place in history, I think it'll end up probably being an iconic launch vehicle, but we'll let the public judge that. And back to your point, Steve, the hardware does what it does because the people did what they were supposed to do. And so at the end of the day, I'm looking back at when we fly this first mission many more missions to come relative to the sacrifices that this whole human enterprise has made to get us to where we are today. So it'll be about the people at the end of the day.
You know, I totally understand. This is a room full of jaded space veterans, but I don't know. I kind of feel like applauding these folks. How about that?